Hello all. Good morning, good afternoon, good evening. Welcome back to another video from Let's DevOps. In today's video, we are going to deep dive more into Bitbucket Pipelines. This is the part 2 video of the series. If you haven't watched the part 1 video, please go to my YouTube channel, Let's DevOps, subscribe and watch out for the part 1 video of how to get started with Bitbucket Pipelines. How do you create your first Bitbucket pipeline.yaml using the starter kit, and how to trigger your first pipeline is all covered in part 1 video. In today's video, we are going to deep dive a little more. We are going to create per se a CI/CD pipeline, not a complete end-to-end CI/CD pipeline, but you will have a build stage, you will have a Docker build, you have an application build, you'll have a Docker build, you'll have a Docker deployment, and all of these stages are netted as a pipeline using Bitbucket pipelines. And I'm going to walk through all the different changes that I had to do to the Bitbucket pipeline.yaml. How did I structure it, frame it, is what we are going to see in this video. So without wasting much time, let's get started. Now, I'm using the same repository that we used for the part 1 video, but then there are a lot more changes I had to do for the Bitbucket pipeline.yaml, and let's actually get directly into the Bitbucket pipeline.yaml and run through the different things that we did. Right, as I said, this is going to be an extension of part 1, so we are going to add few more stages, and or maybe I will probably open it here so that it's even more clear. So we have added few more stages to the existing ones, and let's run through this pipeline.yaml. The first striking thing that you'd have noted from the previous video was that it's all pretty much the same. The start point, you have a base image to start with. I mean, these pipelines are run on a Kubernetes environment, so you definitely need an image to execute all of these tasks, because they are going to get executed in that Kubernetes environment, and so you will have an image. Now, based on what kind of application you are dealing with, it's good to use that base image. So here it is a Maven project, so we are using the Maven image, and so that is sorted. The important striking thing that you would notice is in previously we had something called as a parallel, and now I have removed this parallel argument. Now, as the name clearly suggests, parallel means if you want to get the stages executed parallelly, as in your stage 1, stage 2, stage 3, or step 1, step 2, step 3, and step 4 are independent of each other. You don't want them to be netted as a chain, and if you want to execute them parallelly, then you add that parallel step argument, and then inside that argument you tie the different steps that has to get executed parallelly. But in this case, this is a CI/CD pipeline, so every stage is dependent on the other stage, or even if it's not dependent, I want stage 1 to get completed clean and then move on to next, and then next, and so on. If there is any issue in between, I want the pipeline to break, and that's basically the idea of your CI/CD solution. Right. So I've removed that argument. So now what else have I changed? Step 1, there's been no change. It's not build and test of the application. So yeah, the first stage is actually building and testing your application. Yeah, I was doing some tests, so I just put in hi. Let's uncomment the actual command. Good. Then the second step is the security scan step. So one of our followers had asked a question, hey, can you explain more about this step? Now, there is something called as Git secrets that you can use in your repositories. And when you have this Git secrets, you tend to play with a lot of secrets. Now, this stage basically is a security scan stage, you can say, which comes as a part of the starter kit and mainly looks for any credentials that is sitting in your Git repository. You cannot test it right away. There are a few things that you need to configure, but unfortunately this video is not a dedicated one for that, but we'll definitely do a separate video on the Git secrets and how you can use a security scan tool to catch any secret that is sitting in your Git repository. Not only that, there are multiple scan tools that you can put in as a part of your pipeline, but again, that's for a different video. That's what you call as DevSecOps but that's for a different video. So here, step 2, a basic scan stuff. It pulls this image from Atlassian and then quickly runs through your Git repository to see if there are any secret setting. If not, it will execute clean and move to the next stage. So here is the important piece that we built for this demo. We want to, let's say, containerize an application. Let's say we are building an application here, and then we want to containerize it. And then this containerized application would then get converted into an image. Once we have the image, we want to deploy that image and see if the application is coming up nice and clean. How do we containerize? One of the pretty common ways is using Docker. There are alternatives to Docker. You have Podman, you have Builder, and so on. But here we are using Docker. So how do we containerize this application using Docker? Again, just to stress the point, this is not a video that will delve into the Docker file and explain you how you have to containerize an application. This is going to focus more on the pipeline syntax of how you can use Docker in Bitbucket Pipelines to containerize and to deploy it into the same machine. Right. Step 3, Docker build. As you know, you need definitely a Docker file sitting in your Git repository, and you know the commands to build the Docker file. It's docker build -t to give a name to your Docker image that you want to create, and the context where the Docker file is sitting. Once you do this, the Docker image gets built, and then I do a quick Docker images to check if I can see my image. And once I find that, I do something called as Docker save of this image that I built into a temp image.docker tag. Why do you do so? And even before going there, how do I get Docker into the Bitbucket system? Now this Maven image by default is not going to have Docker. Then how do I bring in Docker? Now Bitbucket have really worked on this feature wherein they have different services that you can leverage. So if you want Docker, then you just use something called as services Docker added to your step, and then the environment will now support any Docker commands. So it's like Docker is now installed, and then you can start using Docker, which is a very cool feature. Otherwise, you should have this Docker installed in the environment that this uh, pipeline is getting executed, or you need to package it into the image, and it gets really complicated. So just use something called as services-docker, and then you'll be able to start using Docker and Dockerization, Docker content, Docker commands right away. Why should we save this image as a temp image.docker is because we are only building the image in here, and in the next step I'm going to deploy the image. If I don't do this, if I don't save it in artifacts as a temp image, the image gets lost because every step is a new fresh spin up of a pod. So nothing that happens on the previous step gets carried over to the next step. So if I don't have this, and if I try to deploy my Docker image that I built in here, it would say that, sorry, I'm not able to find your my Docker. It does not exist. How do I know? I mean, I just played around with this pipelines before making this video, and I did encounter the same thing. So I just went ahead, researched, and then this is the best way that we can pass on uh, Docker images to the next stage. Okay, good. I've saved it as a temp image Docker, and I'm passing it on to the next step. Here, basically, once the image is done, I want to deploy the image, because since we are not using any registry here, we don't have a Docker Hub. I mean, we can definitely make another video of a proper CI/CD, different stages stuff. But here, I just want to temporarily save it somewhere and then retrieve it and then start deploying it on the same machine. So Docker deploy, I load the image from this temp image Docker that I've saved as artifacts. Once it's loaded, I again do a Docker image to check if my image is back. Once it's there, then I run a Docker run -8080. I'm hitting it on port 8080. The image, it's basically an Nginx image which I want to run on the port 8080. And once it's there, I do a curl of the localhost 8080. You'll see this welcome to Nginx page. And to see that, I create output.yaml, and then I also save it as artifacts so that it sits on the artifacts on Bitbucket, and then I'm able to see it visually. Leave this part if it's a little flaky. We are going to dive into the demo now so that you have a better understanding of how things are actually looking visually. So this is just the explanation part. Now I've already done some dummy change to this file, which you saw. Let's go ahead and commit and push this changes, some sample changes, and I give a commit. You know that we have set up this continuous integration. The moment I push the code changes on Bitbucket, there should be a pipeline getting kickstarted. Let's see. Boom. You have the pipeline that gets kickstarted. Let's get into it. This is going to be interesting. Now you see it's a proper pipeline that is netted as a chain. And since we have removed the parallel argument, each of the stage is going to execute first and then pass on to the next stage. The first stage is going to do the application build and then move to the security scan, then the Docker build and Docker deploy. By the time this is running, let's quickly go to the source code and maybe on a high level see what we did on the Docker file. So as I said, this is a Nginx Docker file that I used, basically just taking it from an Nginx image, exposing it to port 8080, copying a few configurations for the Nginx conf, default conf, and then ensuring that it is not run as a root user. And yeah, it's a pretty basic Docker file. Again, we are not going to deep dive into it. We'll make another session on this. But this is the Docker file, and all the configurations that you need is also put into the source code, like the default conf and stuff. Yeah, that's pretty much it to touch upon. Coming back, yeah, step one is done. Artifact, you should see under target, there is this myapp.jar. So all good. It has no connection. We are not actually containerizing this application in the Docker file. It's just to show you that you build and test an application in stage one, and then you do a security scan, and then you do a Docker build, and then it's a Docker deploy. So there's, don't wonder, hey, you built a Maven project, but then you're containerizing a Nginx image. So what's the deal? It's just to show how we can tie up things. Right, Docker build. What's happening? Let's go here. First, we want to build the Docker file, and that's what is happening. You can see that the Docker file is getting built. Stage steps 2, step 3, all of it is good. And then I named the image as my Docker, and that is what I want to check. Docker images, you get my Docker, all good. And I want to save this as a temp doc image so that I can pass it on to the next step. That is also done. Boom, good. With that, this step is complete. And then I come to the next stage where I want to deploy. Before that, I want to load it from temp image. So it gets loaded. I go to the next step. I check if it's loaded. I check if I can see my Docker. Yes, it's there. Good. Then I publish it into port 8080. And now I do a curl of the local host. I get an HTML. Basically, this is not a cloud environment where I can expose it to a service and then on the fly open a browser and then check. So instead, I get the response, but I'm writing the response to a file, a HTML file. You see that I'm doing a curl host again, and then I'm writing the response to an HTML file, and just making sure that if it exists, it should be there. And I'm saving it as artifacts, which means it will come over here. And let's download it. Yep, if I open this, boom, you get welcome to Nginx, which means the application was containerized clean and has also deployed clean. Well, that's pretty much it for today's session. I hope you have some takeaways. Thanks all for watching. We'll see you all in the next another video. Keep supporting. Take care. Goodbye.